Hey there, we are going to talk about parallel and perpendicular lines in this video and talk about them in terms of their slopes and how their slopes are related. Okay, so first off, let's start with parallel lines. So I'm pretty sure you know this, but we'll just do it just to make sure. So parallel lines are two lines that are not going to meet. All right, the symbol is kind of looks like the L's, the two L's in parallel. And if we look at them as lines, they are two lines that are never going to meet. The reason why those two lines are never going to meet is because the distance between them never changes. So that distance between the two lines is always going to be the same. So they're never getting closer together, so they will never intersect each other. Now, if we look on a graph, why would parallel lines not intersect each other? So I'm going to start off with, let's say we have the equation y equals 2x plus 2. Okay, so if we were to graph that, we're going to start at 2, and then the slope is 2 over 1, so up 2 over 1, up 2 over 1, or you could go down to left 1, down to left 1, and so on. But what we end up with is, I'm just going to borrow this little piece of paper here to make myself, oops, even though I'm not doing a very good job. Whoa, yikes. There we go. Okay, that didn't turn out as bad as I thought it was going to be. All right, so here's our first line. So if we wanted a line that was parallel to this one, what's going to happen is the line that's parallel is going to have to move at the same rate or pace as the line that we already have. So that would mean that, let's just say we started one down here. So here's one at -3. If this line that's going through -3 is going to be parallel to the one that we already have, then it's also going to need to go up 2 over 1, up 2 over 1, up 2 over 1, because if it does anything different, it's going to end up getting closer to that line. So let me see if I can do a better job of drawing this one here. So what ends up happening is lines that are, I think that was actually worse than the last one. I don't even think I'm touching the paper there. So lines that are parallel because they move at the same rate or the same pace, which means that the slopes are the same. So the equation of this line that I just did would be 2x minus 3. So what we say is that lines that are parallel have the same slope, but they'll have a different y-intercept. All right, so parallel lines have the same slope. So parallel lines have the same slope. So if you were given a line and asked to find a line that's parallel to it, you know that the slopes of those two lines are going to be the same. All right, so let's talk about perpendicular then. All right, so perpendicular lines, hopefully you remember that means that they intersect and form a 90-degree angle. So perpendicular lines. So perpendicular lines are where they intersect, and when they do, they make actually 4 right angles. We only need to label one of them. So the symbol for perpendicular lines looks like an upside down T. So that's just because we could put that little angle mark in the corner there. So let's say if we're looking at these lines that we were just doing a minute ago, if I wanted a line that's perpendicular to, let's just say the original one, which is this one on the left, if I want a line that's perpendicular to that, that means it's going to have to cross like this so that I make a right angle. Okay, so let's think about what that means. First off, if my original line has a positive slope going up to the right, the line that's perpendicular is going to have a negative slope, which is going to cause it to go up to the left. So one thing I know about perpendicular lines is that they are opposite signs. So perpendicular lines have, so I'm going to say opposite sign, because I know, and let's say that, let's turn it this way. If this were our lines originally and I wanted a line that's perpendicular to it, these original lines have a negative slope, but the line perpendicular to it is going to have a positive slope. All right, so I know that they're going to be opposite sign. But also what's going to happen is we're going to have to do the opposite of the slope. And by that, I mean reciprocal. So let's say we start at the same point right here at the 2. This one is going up 2 and over 1. So for this one, I'm going to have to go up 1 and left 2. Or instead of going up 2 and right 1, I'm going to need to go down 1 and right 2. Down 1 and right 2, and so on. So the slope is not only going to have to be the opposite sign, it's also going to have to go in the opposite direction, meaning that we're going to use the reciprocal of the slope. So basically, we are switching the rise and the run. And so if I do that, then I end up with lines that are perpendicular because I can have that right angle mark right in there. So if we look at this original line that was in red, that one, again, the equation was 2x plus 2. But the line that's perpendicular to it has a negative reciprocal for the slope. All right, so how would this be asked in a question? Well, let's say that, for example 1 here, I want you to write a line that is parallel to, let's just say 2x minus 5, but it goes through the point, oh gosh, I don't know. How about the point 6, 1? I'm just making this up. All right, so hold on a second. Let me back this out so you can see that. All right, so let's write the line that is parallel to this one, but it goes through this point. Okay, so what that means to me is that I know that this is my x and this is my y, and I know that since it's parallel, that the m is going to equal 2. So I can fill my numbers in. So we could say 1 equals, for y equals mx plus b. So that would be 1 equals 12 plus b, so b is negative 11. So the line parallel to this one, but through that point, would be the line y equals 2x minus 11. So this line is parallel to this line. Slopes are the same, but it goes through that point. Okay, let's just say using the same problem. All right, so for example 2, let's use the same equation and point, but let's do perpendicular. All right, so let's make this line perpendicular. So I'm going to use, again, the same line and the same point. Okay, so if the line is perpendicular, I'm still going to use the point 6, 1 for the x and the y. But this time, I know if my slope of the original line is 2, the slope of the line that's perpendicular needs to be negative 1/2, because it's the reciprocal of this one, opposite sign. All right, so let's fill those in. So y equals the m times the x plus b. So this is 1 equals, so half of 6 is 3, but it's negative. And then, oops, kind of running out of room here. So we would say that b is 4. So the line that's perpendicular to this one going through this point is the line y equals negative 1/2 x plus 4. So what I know about these three lines, I know those two lines are parallel, and this one is not only perpendicular to that one, it's also perpendicular to that one. All right, so just to kind of summarize, lines that are parallel have the same slope. Lines that are perpendicular use the opposite sign reciprocal slope. I forgot the word slope here. So opposite sign reciprocal for the slope. All right, I think that takes care of everything. So now let's go practice.